I got my year correct today. It's a miracle. I will say that on Sunday I wrote the year wrong twice, and it wasn't until the second time that my daughter corrected me and said, Mom, it's 22. So, as we were sitting in church, she corrects me. Okay, so lesson 8.1, it says parabolas review. Review in that, yes, you know some about parabolas, but then there's also a new aspect of parabolas that we're talking about today. So parabolas, up until this point of your life, have either opened up or they've opened down. Well, once you hit trig, which this is officially a trig topic, parabolas can also open sideways. And so we have that aspect that is part of this. So this chart, and I will tell you up front, there's a chart for parabolas, there's a chart for ellipses, there's a chart for hyperbolas, and you will have these on the test. So it's not a memorization thing, it's just a knowing how to understand all this information, how to use it. We have two different setups here. I usually call it the left column and the right column. The left column, so right here at top, this x minus h squared equals 4p times y minus k, that is your basic setup for a parabola that opens up or down. And if you look closely, the basic parabola you know is y equals x squared, right? Like that's a parabola you've known for a couple of years now since Algebra 1. Well, if you look closely, there is y equals x squared. That is of the setup y equals x squared. It just looks a little bit different. Okay, and then that h and k is going to be the vertex because our parabolas are not always centered at 0, 0. For a parabola that opens up or down, our axis of symmetry is always x equals a number, and if you recall from Algebra 2, it's x equals the first number of the vertex. Okay, we're also going to talk about something called a focus. And I have a visual here of a parabola, and a focus is a point that is inside the parabola, and it is, how do I want to say this? It is the same distance from the vertex as it is from this perpendicular line called a directrix. Okay, so we have a few more aspects of parabola that are new, I know. But, so vertex, of course, you know, is right here at the base of your parabola. The focus is a point inside the parabola, and it's, I believe, equidistant from the vertex and the two sides there. But that focus, notice the distance from the vertex to the focus is something called a focal length. So that's determined as focal length. If you'll notice over here, focal length is determined as p. That's all in the chart there, right? So that distance is p. That is also the same distance going from the vertex to the directrix. And the directrix, it's an invisible line like the axis of symmetry. It is perpendicular to the axis of symmetry. So your axis of symmetry obviously goes through the middle of the parabola, cuts it in half, is symmetric. The directrix is perpendicular down here. Okay? You'll notice the directrix is y equals, and it's going to be y equals a number. It's going to be y equals k minus whatever the p value is. And again, p being that focal length. We also have something called the focal width. Focal width is the distance across the parabola through the focus, and it's the absolute value of 4p. So I just run through this chart real quick. I'm going to keep going back and referring to that chart as we go through problems. And so you'll become more familiar with everything on there and how we can use it. Now, that's the left column. One of the big things when we start looking at example problems, the first thing I'm always going to ask you, okay, is this parabola a left column or a right column parabola? Because the other column parabola, what's different about these? Notice the parabola, instead of opening up and down, opens left and right. So these are your sideways parabolas, which do exist. We just haven't worked with them up until this point. Notice the difference here. Instead of it being y equals x squared, notice it's going to be x equals y squared. So your x and y, since this parabola goes from being a vertical to a horizontal parabola, the x and y's flip spots. Okay? Your vertex is still HK. Your axis of symmetry. Well, now since it's a sideways parabola, your axis of symmetry is a horizontal line. So it's y equals, and instead of y equaling the first number, it's going to be y equals the second number of the vertex, because it's going through this horizontal vertex. You've got how to find a focus. Notice it's h and k, but it's h plus p. Directrix. Well, if my axis of symmetry is y equals, because it's horizontal, my directrix is going to be x equals. And it's going to be x equals a number, because now my vertex is, or my directrix is going to be vertical. Opens left to right. Notice focal length is still p. Focal width is still absolute value of 4p. Okay? You're going to want this chart beside you as you do homework. I'm going to want this chart beside me. And I realize being on the BenQ this year, it's going to be a little more difficult because I can't just point, but I'll just flip back and forth between screens. Okay. Ready to look at example 1? See what kind of things we're looking at here? These examples want us to write the equation of the parabola, given the following information. So, as we're writing the equation, that means we're either going to write the x minus h squared equals 4p times y minus k, or we're going to write the y minus k squared equals 4p times x minus h. So in all of these, in order to write the equation, you're going to have to know x and h, or excuse me, h and k, your vertex, and you're going to have to know your p-value. Okay? Now, as we go to write this equation, let's look at what they give us. Directrix is x equals 2, and the focus is negative 2, 0. Thoughts on if this is a parabola from the left column that opens up or down, or if this is a parabola from the right column that opens left or right. There's a way to tell. Yeah.
Is it left or right?
And why would you say that?
Because the focus uses h and k, and since it's just 0 is the k, and the left and right focus just kind of leaves the 0 with the comma.
Okay.
So h plus p would be negative 2.
Okay. I could go with that argument. I personally see an easier way to tell, but I'm not going to disagree there. Yes?
Your directrix x equals?
That's what I would zero in on. The fact that my directrix is x equals, in which column, and I'm going to bounce back and forth here, guys, in which column is my directrix x equals? And that's in this right column where my parabola is a sideways parabola, right? So first thing I'm going to do is I'm going to take this equation right here, and I'm going to write it down because that's the equation I'm trying to fill in on my example. Okay? So I'm going to know that I'm trying to fill in y minus k squared equals 4p times x minus h. That's my goal there. And as I look at that goal, realize I need to know h, k, and p. Those are the pieces I need to know. Now, let's see. Connor was talking about the focus being negative 2, 0, right? And again, there's a couple of different ways we can look at this, but the focus being negative 2, 0 will help. The directrix being x equals 2 will help. And actually on this one, I like to draw a picture on some of these. Because if you're struggling to know, I'm going to sketch a little picture here that I think will also help. The focus is negative 2, 0. Where is negative 2, 0? That's over there, yes? So right here, that's my focus. Now I'm just drawing a sketch to help me out. I'm not saying you're going to have to draw a sketch all the time. And some of you would very well scoot through this problem without drawing a sketch. But I think it's also a good tool to have. Okay? A directrix of x equals 2. Where's x equals 2? That's right here. And remember, the directrix is a line. So what does the line x equal 2 look like? That's that vertical line there, yes? So this line right here is my directrix. Thoughts on which way my parabola opens? You guys seeing it? Which way is this parabola going to open? Yeah, to the left. Okay, I got Jacob back there pointing, not Nick, Jacob. Okay, but it's going to open to the left. And how do we know it's going to open to the left? The focus is inside the parabola, yes? Now, I just started to draw it without asking you guys an important question. Do you know where the vertex is based on just looking at this picture? At the origin? How do we know this vertex is at 0, 0? Because the vertex is equidistant from the focus and the directrix. Does that make sense? So that's how I know right there that if I sketch my parabola, my vertex is going to land at 0, 0. You follow all that? Okay, because that's what you have to do. So you have to take the information I give you, you kind of have to dissect it. Now, if we say the vertex is at the origin, in other words, 0, 0, what pieces of information does the vertex provide me in my formula? According to your chart, vertex is what? What letters are these? H and K. So right here, we had to know the vertex. And we know it to be 0, 0. And again, that's just knowing that the vertex is halfway between the focus and the directrix. Now, the other piece we have to know is we have to be able to find P. Thoughts on how to find P? Actually, technically, I would argue we could just find P by looking at the graph. But I'm going to show you another way as well. I'm going to jump back pages for a moment. In our chart, what did it say about P? P is the focal length. Where is the focal length? It's a distance from focus to vertex or vertex to directrix. What is our distance from vertex to focus or vertex to directrix? 2. Now, one thing I will tell you, and I'm going to show you how we can do this without just having to look, and I'm going to use the directrix to do that here in a moment, but I am going to tell you your p-value is actually going to be -2. How do I know it's -2? Well, okay. Think about traditional parabolas. We're used to parabolas either opening up or down, right? When a parabola opens up, we have a positive value. When the parabola opens down, we have a negative value out front, yes? Compare that to left and right. Guess what? When the parabola opens right, that's kind of like opening up. It's going to be a positive p-value. Because my parabola is opening left, my p-value needs to be negative. So opening left is like comparing to opening down. Does that make sense there? At least that's how I compare. Now, if you're a little like, I don't like having to know if that p is positive or negative, I would find p, I would use my directrix information. the directrix we're given here is x equals 2, correct? And if you go back to that previous page, well, not previous page, go to the top of your notes. If you go back to the top of your notes, first of all, which column am I working in? I'm working in the right column. What does it say about the directrix? X equals h minus p. Can we use that information? Yeah. My directrix is x equals 2. My directrix is also x equals h minus p. Do we already know h? What is h? H is 0, isn't it? And so with that information right there, you can use that to find p, in that x equals h, which is 0. That's not how I want to do that. Let me back that up a moment. I don't like how I did that. If x is 2, that's how I want to do it, I guess. If x is 2, because this is 2, right? H minus p has to equal 2. But we know h is 0, right? Somehow or another, I'm not showing it the best, you want to see the connection that if h is 0, 0 minus p equals 2. Okay? If I then divide that negative over, you're going to have that p is negative 2. You guys make that work for you one way or another? Okay, and everyone's, again, this is one of those things. Some people will like the drawing. Some people will like just doing the algebra. Okay, can we write our equations? Our equation. We found that k is 0. We found that h is 0. And we found that p is negative 2. So when I write my equation, y minus 0 squared equals 4 times negative 2, which is negative 8, times x minus 0. Now, if my h and k were anything other than 0, 0, this is the form I would leave it in. Because h and k are 0, 0, do I need to leave it written out like this? No. You can basically drop the zeros off, and basically I'm going to say y squared equals negative 8x. And again, I'm only doing that because h and k are zeros. If h and k were anything but 0, I would leave it in that written out form. Okay. Questions? Okay, well, if you're ready, start looking at V. Vertex is 3, 4. Focus is 5, 4. We need to write the equation. One way or another, you need to figure out, is this a left column parabola that opens up or down? Or is it a right column parabola that opens left or right? And we can do that by taking the information about the vertex and focus and looking at the chart. I can tell you right now by comparing that vertex and focus to the chart up top, whether this is a up and down parabola or a sideways parabola. Or draw a picture. That is helpful too. If I start to sketch a picture, my vertex is 3, 4. My focus is 5, 4. So I've got a vertex and a focus, which you'll see me label like that a lot when we're doing parabolas. I'll put a V next to the point for the vertex. I'll put an F next to the point for the focus. So now looking at the picture, I have another reason to know whether this parabola opens up or down or left or right, because of the relationship between the vertex and the focus. So what are we saying about this vertex or this parabola? What's it doing? It opens to the right. Okay, and we know it opens to the right because my focus is inside my parabola, and so based on where the vertex is, and this is just a sketch, is that the exact shape of my parabola? No, that's not what I'm saying. That's just a sketch, but that's the idea that I know that it opens to the left or right, in this case specifically to the right. So based on that information, I know when I go to write my equation here at the end, I'm going to be using the form y minus k squared equals 4p times x minus h. Are we okay with why I picked that formula? That's the one at the top of the right column where the parabola opens left or right, correct? So that's why I picked that formula. Like earlier, I need to know h, k, and p. Well, what do we already know? If my vertex is 3, 4, what's that tell me? Those are h and k, correct? Which, by the way, before we drew the picture, did some of you have this pinpointed as a sideways parabola? Let me address that just real quick. If I go back to this chart, looking at my chart, knowing that my vertex was 3, 4 and my focus was 5, 4. 3, 4, 5, 4. How does that help me know? Notice right here, when you look at your vertex and focus, in this one I have K and K being the same there, don't I? And so that's how I know if it's 3, 4 and 5, 4, those 4s have to match. So I didn't have to draw a picture. And this is where some of you are not going to be a picture drawer. Some of you are going to love drawing pictures. It's all a matter of how you see the math. Okay? But that's how I knew it has to be a right column without even drawing a picture. Are we okay with that? Now, for the focus, it's h plus p, comma, k. And my focus is 5, 4. So that is h plus p, and that is k. Thoughts on p? I've got 2 easy ways I could tell you p at this point. Connor?
Is it 1?
What?
1.
Not 1. Ethan?
Is it 2?
2? Why is it 2? What's your reasoning?
The distance from the vertex to the focus.
Okay. If you look right here in that picture, from 3 to 5 is a distance of 2. How can I tell by looking here? If h plus p has to equal 5, and what do we already know about h? H is 3. So 3 plus p equals 5, and thus p equals 2. Are you okay with the fact that p is positive 2 this time? My parabola opens to the right. So it should be a positive 2 this time. So we know that H is 3. We know that K is 4. And we know that P is 2. Can you write that equation? And this time we're just going to write it and leave it in that form. In that y minus 4 squared equals 8 times x minus 3. Okay. And that is our standard form of a parabola. And notice by looking at that, you can tell the vertex right off the bat, can't you? By pulling out your H and K. Questions on this one? Okay. One more on this page, then we'll look at the back. We have 3 pieces of information shared about the parabola. It opens left, the vertex is negative 3, 2, and the focal length is 2. I personally don't feel the need to draw a picture on this one. Everything is provided for me, in my opinion. Jacob?
This one opens left.
You think it opens left. Now, here's what I want to know. What does opening left tell me?
P.
P is what?
Negatory.
Okay, because it opens left, I automatically know that P is negative, yes? You've got to watch out for that. Okay, it opens left, P is negative. Now, also if it opens left, does that tell you which equation to grab? You're grabbing that same equation again of y minus k squared equals 4p times x minus h, because it opens left or right. Okay, what else do we know based on the given information? P is negative. Anything else? H and K? If they tell us the vertex, they are providing H and K. So I know H, I know K, I know P is going to be negative. I just need to know what P is. Okay, focal length. That may or may not be one that's stuck in your head yet, so I'm going to take us back to the chart at the top of the page. We're in the right column. What does it say about focal length? Focal length is P. Oh, that's helpful. So what does this say? If the focal length is 2, then P is 2. Well, kind of. What do we have to take into account, though? Okay, so the focal length is 2, so that distance is 2. But because this opens left, then we're going to have to use the fact of P being negative 2 because of that. Okay, can you write your equation? Huh. Did you guys catch my mistake when I wrote my equation, my basic equation earlier? I wrote 4 instead of 4p. That should say 4p right there. I don't know what I said out loud, but okay, so we know P is negative 2. We know H is negative 3. And we know K is 2. Write your equation. Y minus 2 squared equals negative 8. X minus negative 3 means I'm really going to write x plus 3. Okay. Obviously, you have some up and down ones mixed into homework also. Okay. I haven't shown you all the different options. Okay. I've shown you a few options and how to mix in that chart. And you're just going to have to take the information they give you, take the chart, and see what you can figure out between the two of them. Obviously, tomorrow you're probably going to come back with some questions, on the ones that you get stuck on. And that will be our job tomorrow to figure out some of those, missing pieces. Now, on the back, it's graphing a parabola on a calculator. What has to be true? I mean, as you look at equation A there, what has to be true to graph that on your calculator? It has to be y equals. So these three on this page are all about the fact it has to be y equals. So you need to solve for y. Now, we'll see if we can get through all three of these. If I push, maybe. Notice there's some steps up top. Solve for y. Sometimes you have to complete the square to do this. We need to get to example C to show that. Type the equation into y1, sometimes y2 also, when you have to square root, and push the graph button. Okay. A, y minus 4 quantity squared equals 8 times x minus 3. Well, I'm pretty sure that's one of the parabolas we just had up front. It is. That's example B. Now, how do we solve for y? If it's y minus 4 quantity squared, first step is going to be, if it's y minus 4 squared, we're going to square root to get rid of that square. If you square root the left, we got to square root the right. Now, as I square root, what's the square root of y minus 4 quantity squared? Y minus 4. What's the square root of 8 times x minus 3? The square root of 8 times x minus 3. What happens when you take the square root in an equation setting?
Plus or minus.
Plus or minus. So don't forget that plus or minus out front, or you're only graphing half of your parabola. How do I solve for y? You're going to have to, add 4 to both sides. When I write this, y equals, I like to have my plus or minus in the middle of two things. So I'm going to say 4 plus or minus the square root of 8 times x minus 3. And that's what you're graphing. Now, what's the catch to graphing this? Where's your plus or minus button on your calculator? We don't have one, do we? So when you go to type this in your calculator, realize you're typing in two equations, and that was a hint given up top, that you're going to be typing in 4 plus the square root of 8 times x minus 3. And you're going to be typing in 4 minus the square root of 8 times x minus 3. Okay? You'll want to type both in because we do not have a plus or minus. Okay? Now, how do you show me that you graph this on your calculator? You sketch a graph. Okay, so that's what I will be expecting, is that you sketch a graph. If you were smart about this, can you tell where the vertex was? The vertex had an x with a 3 and a y with a 4. So my vertex is actually at 3, 4. And so if we three, 4, and then one thing I would check, when I graphed this on my, previously on my own, I did look and see that where does it cross that x-axis, and it looks like it crosses maybe around 5. Is that what it is? So, which makes this one really awkward to draw because it's really wide, but it gives you an idea. Okay. Running out of time, and my goal was to get through this lesson today. Are we okay on A? Okay. B, you're going to solve this for Y. No tricks. Because what is there? There is just a Y term. And so if you just have a Y term, you're just going to move everything to the other side. And so it's, no tricks there. You would subtract your x squared over, add your 7x over, and add your 2, all over to the other side. So subtract the x squared, add 7x, add 2. When you do that, you're going to have 3y equals the negative x squared plus 7x. And then if you go ahead, 9 plus 2 is 11. What do you do to solve for y? You're going to divide by 3. And based on the fact that I'm putting this into a calculator, I would just leave it as one big fraction. And I would graph it like that. Okay? On this one, notice it's y equals a negative x squared. You get an upside down parabola. And I would check out where that vertex is and whatnot. Okay? I have the vertex around 3.5, almost 8, 7.75. So something around that. Now, C. I'm not going to have time to get all the way through this, but I need to mention it so you know what you see. Okay? What's different about C? When I go to solve for y, it's not like A where it was y minus 4 squared, and I can take the square root. It's not like B where there's just a y term. It has a y squared and a y term. Folks, that's your clue. You have to complete the square when you see a y squared and a y term. So I may have to finish this one tomorrow, but to give you some of the basics, we're going to complete the square. This is an equation. I want to start by keeping my y squared and y term on one side, moving everything to the other side, which means I'm going to move my 6x and my 13. I'm going to add 6x over and subtract 13. So then I have y squared plus 2y, leaving a gap. And I'm going to have equals 6x minus 13. You remember how to complete the square? B over 2, quantity squared. What is B? B is 2. So you're going to be doing 2 over 2 quantity squared, which is going to be 1. What do I do with that 1? You add 1 on the left. If you add 1 on the left, you add 1 on the right. And this is where you will factor that. And then it will be like A. Okay? Give that a shot. See what you can figure out. Obviously, I probably need to do a complete the square in class tomorrow, right? So I will make sure I do that.
Did you just find the vertex by counting on the graph?
Yes. Yeah. Kind of like doing a trace. Yep. When we factor this would end up being y plus 1, and you would go from there. So I can come back and talk about that tomorrow if I need to.